Hello and good evening, friends. It's 3 o'clock, and let's start this session where we discuss the interview preparation questions regarding data science and the related topics. So let's start with the first question. Let's start. What is multicollinearity and how do we deal with it? Okay, I see a message that there's no voice. Am I not audible? Please confirm me if I'm not audible. Right. Hope I'm audible right now. So yeah, so we were discussing about multicollinearity and how we deal with it. Yeah, thank you, Sanjay. Kind of correct, Ipshita, but yeah, it could be a little more, explanatory when you answer the, questions. So multicollinearity is something that gives you an information about a collinearity between independent variables. All right. This is one of the assumptions in linear regression and logistic regression. All right. And it can be identified with a score called VIF score, right? Which implies that if the VIF score is greater than 2 point, less than 2.5, it is moderate. And if the VIF score is considered to be high, if the score is greater than 5, right? Getting me? Yes, Sanjay. Yeah, it is used in multilinear regression and logistic regression as well. Oh, is it static? Yes, Ipsita. So basically, you can deal with it by removing the variables which are of high VIF scores, and again checking the collinearity, multilinearity. Yes, you can do that. You're right. So as I was explaining, you have to remove the variable which has high VIF score, and again check for a VIF score for the multicollinearity. And if the VIF score is less than or equal to 2.5, you can go ahead with the further process, or else you have to again check for the variable which has high VIF score and try to remove it. Or else let's go to the next question. So we were discussing about VIF score. Now let's discuss about VIF. What is VIF? Yes, Neelam, you're right. So VIF stands for variance inflation factor, which detects the multicollinearity as we were discussing earlier, right? In the regression analysis, right? It basically shows whether the predictors or the features are correlated to each other. Depending upon the correlation VIF score, we know move further in our model building. Am I not audible? All right, thanks for responding. Yeah, I hope I'm audible to everyone. Thanks. Now let's go to the next question. Friends, uh, there will be a latency between the YouTube streaming and the Zoom meeting. So I hope you get it, and you have to bear with it. Thank you. Upendra, it's not about overfitting. We are just talking about the variance. That is the you know difference between the variables. Hope it's understood. All right. So yeah, let's go to the next question. What is entropy? Yes, Neelam, you're right. So entropy is the purity in the data that we have without homogeneity and a lot of differences. We actually use entropy while we are working on decision trees, right? It can be considered in a way that the higher the entropy is the data with differences. Lower entropy is the data with homogeneity. So as we are discussing, the entropy is the data is considered to be good if the entropy value is low. Yes, Christopher. Exactly, Ipshita, you're right. Now let's have another question regarding entropy. What is the range of the entropy value? Yes, Neelam. So the range of entropy values vary from 0 to 1. When the score or the value is near or equal to 0, the data is said to be low entropy value and the data is said to be good. If it is near to 0, near to 1 or 1, the data is said to be bad with a lot of differences. Upendra, information gain is another different topic that we'll discuss in the later part of the session, right? Now, let's discuss about the formula. Since we are talking about the entropy, let's have a mathematical form of entropy. So the formula is minus p into log base 2 p. So p is basically here the percentage of the positive and the percentage of negative node. All right, let's break down the formula. All right. Hope this is visible. Okay, I'm presuming that my screen is visible, right? Yeah. So when you are considering a node, assuming it is a parent node, and these are the decision nodes that are yet to be further classified, right? And when you're considering parent node and further classifying it to decision nodes, the positive nodes are the one which are considering it as a binary classification problem with yes or no, right? Number of positive nodes are number of yes, and number of negative nodes are number of no's. So the percentage of positive nodes into log base 2, the percentage of positive nodes minus the percentage of negative nodes log base 2, the percentage of negative nodes. Since I can't you know write the exact formula, that's how I break it down in a word format. Please let me know if you are not understanding it. I might little narrow down and explain it in a better way. Is this formula on entropy understood? Right. In that case, let's go to the next question. What is information gain? Right, let me wait for a while until you answer. I guess Upendra was actually trying to explain about it. Now that we are in the topic, Upendra, would you try to explain about it? Right, Christopher. So this is the information between the entropy before splitting and the entropy after splitting. All right. And it is inversely proportional to the entropy. And also, entropy gives you the information about a single node, whereas the information gives you the information about the all combination and selecting a node which is viable for making a decision furthermore and going going to the end node, leaf node. So information gain is decrease in entropy. It computes the difference between the entropy split and the entropy after split. All right, let's also discuss about the formula of information gain. All right, so this is the formula where information gain S of A is equal to H of S to the summation of S of V by S into H of S of V. So now let's go deep down into the each values. H of S is actually the entropy of the root node, right? And S is total subset. S of V is subset after the split, right? H of S of V is the entropy of the total subset. All right, I'll wait for a while until you know have a screenshot of this formula. So as I was talking about the relationship between entropy and the information gain, it is inversely proportional. So the higher the information gain is, the higher the chance of splitting the decision tree accordingly, right? Let's go to the next question. What is an impure subset? Right, let me wait for your answers. All right, impure subset is said to be a decision node where the percentage of positive and the percentage of negative, considering it's a binary classification problem that we are referring to, is zero. I mean, is 50-50 and the same. For example, the number of yes are three and the number of no's are three, where it is a 50-50 consideration, where the entropy value of that would be one. So that particular subset is known to be as impure subset. Ikshita, Guinea impurity is yet another different concept, which is, you know, which we'll be discussing in the later part. Of course, it is related to impure subset, but Guinea impurity isn't a right answer, right? So impure subset is a subset where the percentage of yes is equal to the percentage of no, which has an entropy value of 1 byte. And let me also stress on this. The units of entropy is calculated in byte. So how to deal with it? Like we will, according to the information gain, will change the node. I mean, the parent node that we take, and further do splits. Got it, Neelam? I mean, the main aim of a decision tree should be the leaf node, or any particular node where the where furthermore classification cannot be done. That is called as pure subset or the leaf node, right? Right. Thank you. Now let's go to the next question. I guess we have already discussed about it, but I'll be happy if you answer it. So how do you consider a decision node to be a valid or a correct node? Let me wait for the answers. All right. The answer could be regarding the decision tree impurity. I mean, information gain and the entropy that we were discussing. You could frame your answer on basis of those parameters. All right. So a decision node can be considered to be a suitable or a valid data split, resulting on their child nodes, right? The higher homogeneity and lower entropy, and also the higher information gain. That's what we've been discussing about, right? Yeah, Neelam, in your answer, like I'd like to add another thing where there is no further classification, where there is no chance of further classification is also another answer. Yes. I'll wait for a while until I get to the next question. Let's go to the next question. What is Guinea impurity? I am waiting for the answers. Yes, Ipsita, like I didn't quite get your answer. All right. So basically, it also gives you the impurity of the data. All right. And this is also one another method which can be used in instead of entropy, which is popular, right? So Guinea impurity is the one that usually be considered while doing ancient tree algorithms, right? So the basic agenda of this Guinea impurity is to decide the optimal split from the root node to the subsequent nodes. All right. And this is a formula for Guinea impurity. I couldn't add a square to it. So basically it is 1 minus percentage of positive nodes whole square plus percentage of negative nodes whole square. Please note it correctly if you're noting it down. It's 1 minus percentage of positivity whole square plus percentage of negativity whole square, considering yes as positive and no as negative. Now let's go to the next question. Since we've been discussing about the formulas and different concepts and pros and cons about the Guinea impurities and entropy, let's have the next question regarding Guinea impurity and entropy. Which one is the better one? All right. And why is it so? Let me wait for your answers. And this could be a potential interview question when you're, attending an interview. All right. So let me try to explain it. Right, Ipshita, you got a better point to be, answering in a discussion or in an interview. You're right. Yes, Neelam. Yes, you're right. Yes, you people are correct. So let me, go with the perspective where considering the formulas of these two concepts. All right. Entropy formula consists of log, right? So basically, a calculation which consists of logs, logarithmic calculations, are way time taking than the normal one. All right. So the computational time or computational cost is less in Guinea impurity because it doesn't consist of any logarithmic calculations. All right, this could be one of the differences or the pros towards Guinea impurity, with where Guinea impurity is considered to be a uh, well desired calculation, right? And the next one is, yes, as Ikshita and Neelam were discussing. Yeah, the index ranges from 0 to 1 in entropy, right? And when it comes to Guinea impurity, it is 0 to 0.5. Considering a map, right, from 0 to 1, all right, on the x-axis, and y-axis consists of entropy value, which is 0, all right. When the difference positivity increases to the maximum level, sorry, this is supposed to be 1 when we are talking about entropy. After the maximum value, it falls down to 1, right? So Guinea entropy, Guinea entropy is where you can find it at 0.5. The maximum range is 0.5, unlike entropy. So this is what makes a huge difference when you're debating in between Guinea impurity and entropy, where Guinea impurity is mostly considered, right? And please apologize for my I apologize for my bad drawing over here. Please consider it. Well, these are the points that we have discussed regarding the computational cost and the max and min values regarding both the Guinea impurity and entropy, which gives us the impurity values for the data set. Yes, Ipshita, as we were discussing, Guinea index is the most preferred when you're performing decision trees. All right, this is it for the day. So we've so far discussed about the impurities and the other terminology in decision tree, right? Let's uh, let's catch up in the next class with a different concept. Right? Hope this session so far has been informative. All right. Just a moment, Neelam. I'm just going through your. Exactly, Neelam. Yeah, you're right. Basically, Guinea impurity is more, you know, I mean, less time taking and also effort consuming when compared to entropy. All right, friends, you have a great one ahead. Thank you so much.